Okay, I'm going to solve the question that you may have, that is how to take from a table, get the pattern, and decide if your pattern is exponential. And after that, get the function rule that explains our pattern. So stay here for a few minutes because I'm going to show you three examples that tells you about the trends. So let's go. You can see here three tables, right? So the three tables are talking about a different trend. So we're going to start with table number one. And in table number one, you can see that you're increasing the independent variable by 1. Okay, it's increasing 1 by 1. And you're seeing that the dependent variable is increasing like a regular number. It seems the multiplication, so what we're doing is multiplying times 3 every time you have the value. Okay, so the function rule when you have exponential functions is given by could be capital A times small a to the x power. Okay, this is the idea of the function rule when you have exponential functions. So this a is the common ratio, so it will be the number that we're multiplying every time in the trend. Okay, so in this case it's 3, so in this case a is going to be 3. And a will be the value when the function is 0. So when x is 0, we're going to have a. That will be the y-intercept of the function. Okay, so in this case, the y-intercept of our function is 3 as well. So we can write this expression as just fx equals 3 to the x power. Okay, but here we have the problem, and you have to include this 3 here, okay? 3 times 3 to the x power, because when x is 0, we need to have 3, so 3 to the 0th power is 1 times 3 is going to get you 3, so the function rule for this function is going to be 3 to the x plus 1. Okay, I'm using properties of exponents, in which we can add, if we have the same base, we can add the exponent. So that will be for table number 1. Okay, so take your time to understand what I'm talking about. Look at what I did, the function rule, common ratio, and using the common ratio, I did the rule. Okay, this is for option 1. Option 2. In option 2, we have an increasing of 1 by 1 in the independent variable. Nice, very good. And we have here that from 0.5 to 0.25, okay, we don't know exactly what is the value, but in order to determine if there is a common ratio, you have to divide two consecutive numbers. So what you gotta do is to divide 0.25 divided 0.5. That's going to get you 0.5. Okay, so you're multiplying by 0.5. Now, 0.125 divided 0.25. So I'm going to use a calculator to see 0.125 divided 0.25. Hey, it's 0.5 as well, so it's probable our common ratio. Let's check it here. From 100, 0.063 over 0.125. So let's check 0.6063 divided 0.125. I got 0.504. 0.504. And finally here 0.031 divided 0.063. So 0.031 divided 0.063. I got 0.492. 0.492. Okay, you can see that even that these two values are not equal to 0.5, all values are around the same common ratio. So in many situations, when you have an exponential trend, you don't need to have exact values because you're finding trends, and sometimes in trends you don't have the exact value, you have approximated results. So in this case that you can see in the table, the value is approximate to 0.5. So we're going to use the function rule as 0.5. So the common ratio will be 0.5. So in this case, a times a to the x power, common ratio will be 0.5. And we don't know what happened when a is, what will be the amplitude, because we don't know what happened when the function is 0. Okay? But you can deduce it. And that's the cool part. How you can deduce it? If this is increasing one by one, it means that if I move up, I will get 0. And if I move up, I will get a number that if I multiply it by 0.5, I'm gonna get 0.5. So what is the number that multiplied by 0.5 gets you 0.5? Yes, is 1. So A, the amplitude, is going to be 1. So now we have our function rule. The equation, or the function rule, will be 1, I'm not going to write 1 because I'm multiplying, times 0.5 to the x power. Okay? And that's how you can work in another trend. Remember, in the first trend we have the regular one, common ratio, easily to find, increasing independent variable one by one. In the second part, we have two deals. The variable is increasing one by one, no problem with that, but we don't have the y-intercept and the common ratio is not exactly the same. So first technique that you have to do is round, in order to have kind of the same common ratio, and in the second part, remember to move up from 1 to 0, you're moving one by one, and move up in the exponential rule. So what is the number that multiplies by 0.5 gets you 0.5. And finally, we're going to see table 3. Table 3, what do we have in table 3? We have an increasing of 3 by 3. I'm going to write it here. 3 by 3 in the independent variable. And here you can see easily that it's multiplying 2. Okay? So the common ratio is 2, right? You don't need to think a lot to know that the common ratio is 2. Common ratio is 2. And the amplitude should be 2 as well. Okay, so essentially this function should be similar to our function of 3, 2 times 2 to the x power, right? But there's a problem here. The problem is that I'm increasing the independent variable 3 by 3 instead of 1 by 1. Okay? So how could you fix this situation? You can fix this situation by multiplying the independent variable times 3. Okay, so in this case, if I multiply the independent variable times 3, what I'm doing is that when I want to say that x is 1, 1 times 3 is gonna get me 3, and that will be this, okay? That's one option. But however, I need that when x is 3, I need to have what will happen here if it will be 1. So instead of multiplying by 3, I'm going to divide by 3. Okay? So let's test it. Let's test it. If x equals 1, I will have 2 times 2 to the 1 over 3. Okay, no, I have no idea what's going to happen. I'm sorry. When x equals 3, I'm going to have 2 times 2 to the 3 divided 3, that is 1. So you will have 2 times 2 to the first power, that is 4. Hey, good, I got the table. You see? Now, when x equals 6, 2 times, let me include a new page so you can see it properly. Yep, when x equals 2, 6, 2 times 6 divided 3, 6 divided 3 is 2, so 2 times 2 to the second power. Oh my god, this is 8. So now we did it. As the independent variable is moving 3 by 3, we need to compress the function in x by 3 units. And this is what I'm doing by dividing by 3 here. Okay? So essentially, that will be the function rule for our third table. So let me help you to sum up the information we found in these 3 tables. First, the 3 of them represents an exponential trend because all of them can use a common ratio for the dependent variable. So it means that the consecutive number in the dependent variable depends on the multiplication of the last number. Okay, that's calling an exponential trend. On the other side, we have one problem. If you don't have the y-intercept, you need to go up in the table according to the distance you have until you reach to 0. And if you move in the distance up, so you can find the number whose multiplication gets you the last one. So 0.5, I divided by 0.5 to get 1, and I found the intercept. And in the third option, remember that if you're adding the independent variable using the same value, you just need to compress or stretch the function, depending on how you're using. In this case, we need to stretch the function. So that's why you have x divided 3. And that's it. And this is anything you can know about exponential rules. Let me know if you have any question. You know where to find me. And let me tell you that next time we can talk more about exponential functions. So remember, check the trend. If you have a common ratio, it's an exponential function rule. Bye bye. Have a nice day.